Hi everyone, I hope each one of you are doing fine and staying safe. Welcome to Data Platform Summit 2020. This is one conference I look forward to every year where it's pretty much coming together the best of the content on data and AI under one umbrella. My name is Sandeep Alur and I work at Microsoft in a unique group called Microsoft Technology Center. As you see the pictures right on your screen right now, that's a facility that I work at. And of course, in the current times, we are basically infrequent visitors to the facility, but that's the facility I work at and host customers every single day. So best part of my job is I get to interact with at least one customer each day, and bulk of my talk today, I'm going to spend some time just to give you a glimpse of what is happening in the world of AI when it comes to its impact, and also because of the impact, eventually the need for each of the ML practitioners, data scientist practitioners to stay responsible when it comes to the outcome, right? So as you see on the screen, yes, I'm going to take you through the journey of responsible machine learning. As Microsoft, we've announced quite a few tools and technologies under the umbrella of responsible machine learning. But crux of what we're going to talk about is the need for model interpretability, right? We'll see what that is all about. Otherwise, pretty much for the next 45 to 50 minutes, you will see some of the techniques, some of the tools. Also, before we get there, it's about the context in terms of the need for tool set to be made available, the need for us to equip data scientists and ML developers with certain tools which will help them stay responsible as they build machine learning models. Okay, with that, we'll get started. Before we dive into the actual topic, I think as techies, as you might be a data engineer or a machine learning developer in the field of data science, doesn't matter, but there's a need for all of us to understand a design philosophy. We can call it as a design construct, which is true to how we are innovating as Microsoft. We call it Microsoft's worldview, which is intelligent cloud and intelligent edge, right? There is no ambiguity in this construct, right? End of the day, all of us understand the cloud part of it, which is definitely mainstream today, and every single service that exists there, which we call cloud native, is something which is actually amplifying adoption to a significant level. But if there is an element which is so dominant today, which is a dire need going forward, and that would be intelligent edge, right? The reason it is important for all of us to understand this construct is because when it comes to machine learning models, it is expected that we can light up all of the intelligent edge devices. When I say intelligent edge, your infrastructure which can be closer to data, right? For example, just to give you a simple example, it can be your mobile phone or a watch or a Bluetooth device which you can interact with, right? Be it Alexa, Cortana, Google Home, doesn't matter. But all of these, typically, which you can qualify them under the umbrella of IoT, right? Or industrial IoT, right? All of them qualify to be intelligent edge devices. Now, in the current times and going forward, there'll be massive explosion of intelligent edge devices. Let's say edge devices. Now, intelligence is secondary, whether you're going to infuse intelligence into those devices. But fact of the matter is, in fact, we are in a scenario where bulk of the businesses and industries globally are looking at how can we take compute to places that matters most to us, right? That way, we can infuse certain functionality, certain, I would say, capabilities closer to where data is getting generated, right? Gone are those days where you have to take data to a specific infrastructure for computation or inferences. In the world of machine learning, yes, inferencing dominantly happens on data that is real time. But then, fact of the matter is, if you look at data, it definitely comes in various formats, right? So, ability for us to take that data to the cloud for inference at times is not practical, right? So, hence, there's a need for us to make these edge devices intelligent by infusing AI and ML capabilities, and that's what is true classic manifestation of intelligent edge device. I'll show a couple of examples to make it very real for you. But at the onset, intelligent cloud and intelligent edge as a philosophy is real, is being embraced by businesses globally, and probably going forward, considering the current pandemic and post-pandemic, intelligent edge becomes a dire need and something which will ensure that the business success depends on how we can make inferences in real time closer to where data is getting generated. Right? Now, talking about the thematic in the industry, yes, we're talking about automation being central to every business. Automation will drive a lot of transformation going forward as businesses reimagine their applications, their I would say softwares. Automation becomes central to how businesses will bring in agility into their business going forward. Two themes here. In most of my talk in the recent past, I've kind of highlighted the fact that yes, intelligent automation, which is basically nothing but robotic process automation, RPA, and AI coming together. That's synonymous to intelligent automation. That's something which is central to every business. And second is, of course, autonomous systems, right? For the first one, which is intelligent automation, you might think of a scenario where there is a human being in the loop, right? Human in the loop is what you talk about. And when it comes to autonomous systems, we're talking about with no human intervention, systems being equipped with certain autonomy to take decisions in real time closer to where data is getting generated, right? Now, the reason why I'm trying to bring in automation as a key is because end of the day, when you infuse automation into systems, there's also an expectation that there should be intelligence in the system, right? Can we avoid human intervention as much as possible so that systems can take decisions on their own and complement the very need for automation? And that's where it's important for us to understand automation and autonomous, they go hand in hand. And this is also a reason when it comes to responsible machine learning, while we're trying to empower machines to take decisions on our behalf, right? Can we ensure that systems are built with utmost responsibility? You've also heard the term called ethical AI, right? Eventually, we talk about responsible AI, responsible machine learning as overall construct and umbrella under which we're looking at how can we bring in certain design principles which will foster the culture of responsible machine learning as we go along. Okay, so simply put, these two, by the way, what you're seeing on the screen right now, these two thematic, which is intelligent edge, which basically is overall worldview of Microsoft, but the thematic, which is intelligent automation and autonomous systems, right? So those become central, and in fact, as we speak more about it, it is very evident that yes, businesses are looking dominantly in those two, I would say, streams. And for the next 5 to 6 years or so, it definitely would be a key differentiation when it comes to businesses thriving in the modern world. Moving on. Now, of course, I said autonomous systems. Let's understand this a bit because, as I said earlier, it is important that we wear the hat of a responsible, I would say, machine learning practitioner to infuse right checks and balances when it comes to interpretations, right? Now, autonomous systems where there's no human in the loop, we're talking about, putting these machine learning models built in a simulated environment into the real world. Of course, at Microsoft, we call it Project Bonsai. This is something which we announced recently in a public preview. So, ability for us to simulate real world scenarios in a simulation environment, which is pretty much the Project Bonsai, train it, look at certain accuracies, and then let it out in the real world. And that's where the transition is happening from machine learning, which is basis historical data, to machine teaching, which basically decides on what is the right decision to be made looking at the current data, right? And that's where Project Bonsai takes center stage. But if you're looking at what are the areas where autonomy is essential, it can be autonomous systems, autonomous vehicles for that matter. It can be logistic transportation or any, I would say control systems where there is a need for, let's say, calibration to happen. There's a need for optimization to happen, right? End of it, it's all a optimization problem. Now, how can we bring in autonomy into the systems, yet make sure there is an element of responsibility? That means decision taken with utmost focus on, I would say, the impact which brings in a positive construct, right? Systems can lead to negative construct as well, but can we look at how can decisions being taken which would have a very positive impact in the society, right? So now, when I said intelligent edge, this is one classic example you see here, right? This is a retail store. There's a machine learning model being deployed there, and we're talking about how can we, track people and calculate social distancing between individuals. Now, the point is, this is when you say intelligent edge, yes, the compute in terms of inferencing the outcome from this particular model, the compute exists within that real estate setup, right? The video feed is not being sent to the public cloud for inference to happen. No, it is actually happening in real time at the store, and that's the power of intelligent edge. Now, when it comes to video feeds, etc., it's easy for us to see video footage and understand whether the system is doing the right thing or not, right? Here, for example, we're looking at tracking people at the checkout counter, an ability for us to track how many seconds are they in that particular zone, right? The intent here is to ensure that we minimize amount of time people spend with right social distancing being managed within a retail setup. But it's easy for any of us to look at a visual and understand whether the machine is taking a right decision. Is machine learning model which is deployed there, is it tracking the right metrics? It's easy for us to do that, but not every problem exists in that particular, I would say, avatar, right? So if you look at a few use cases here, when we talk about building machine learning model, it can be regression problem, a forecasting problem, a classification problem, or a clustering problem, right? So if you look at these a few examples, it can be in a banking domain. As a retail banker, you may apply for a loan, right? It can be a personal loan or a housing loan, right? The system, depending on your credit score, they may approve or reject your loan, right? So, okay, when system is approving or rejecting your loan, on what basis it has been done, right? It has to be done with utmost fairness, right? I mean, what parameters are forcing the system to conclude that yes, loan has to be given to so and so individual, or loan should not be given to the individual. So on what basis? That transparency is so critical. Second, if you look at propensity of an individual, for example, in the police department, right? End of the day, they're looking at reducing crime, and can they proactively take action foreseeing some individual may commit a crime, right? So propensity for an individual to commit a crime, that's also a prediction the machine does, or a proactive wellness. Can we look at predicting a health condition of individual looking at his or her clinical trial data, right? That's also an area where we're looking at prediction to happen. Now you're shopping online, and you're looking at how can we upsell and cross-sell a product to a specific customer, right? Again, this is basis one's personalized choice in terms of what should be upsold or what can be cross-sold to a particular consumer. And finally, end of the day, can we forecast weather calamities aptly, right? Can we avoid disasters, right? Can we save lives? Now, end of the day, all these predictions are done based on some historical data and training, etc. Now, when inferences are being made, right? Today, if you look at it, for many of the decisions that system is taking, it becomes a black box for a person who's trying to understand the inference being made, right? You give certain input. Depending on that input, the system is actually making a decision, and decision is delivered via an output from the system, right? The reason we call it a black box today is because ability for us to interpret the results by way of certain parameters is not easy. For scenarios like yes, approve, reject loan, you can probably build a system where yes, the parameters against which decisions were made, you can call it out, but there are certain problems. Specifically neural network or deep learning problem where it becomes difficult for us to understand what parameters, what features of a specific data led to or complemented or influenced the outcome, right? These questions are hard to solve. And again, when I say hard to solve, they're not impossible to solve. And this is where there's a need for us to look at tool set which will unearth those aspects which will help us address transparency and eventually ensure you build the model in the utmost fairness when it comes to outcome, and also make sure you can interpret aptly and conclude that yes, decisions made by the system is right or wrong. Yeah. Eventually, it's all a feedback loop, right? If the system is doing something incorrect, you can always go back and fix it. The system is doing the right thing. Yes, you can complement that, and you can keep a check in terms of yes, when anything goes off this particular such decisions, can we look at human intervention and fix those things? That's the feedback that we're talking about. And this is the crux of my talk today, by the way. While we're saying black box, it is a black box, and how can we ensure we can peek into the black box and understand what has gone into the outcome that has happened? How can we ensure we surface utmost transparency? How can we ensure we stay accountable on the outcome, right? This brings to the point where, as Microsoft, yes, we've been talking about responsible AI for some time now, and we are the strong advocates of responsible machine learning, right? The trust within the system only comes in when you demonstrate that the system you built in has followed certain guiding principles. We can call it responsible machine learning design principles, right? The 6 of them that you see here, with fairness, reliability, inclusiveness, privacy, transparency, and accountability, right? The need for us to look at the systems and make sure that each of these 6 design principles are looked into, right? Making sure that yes, when we're building the system, we have stayed true to each of the 6 principles is a dire need. I mean, not every system can look into all the 6 and make sure there's a tick mark. It's not a tick mark, but it's an iterative approach, right? As you build the system, as you get more data, as the system demonstrates better accuracy, it's always required to go back and look as to how the decisions are being made and validate them, so that when time comes, when there's a need for us to demonstrate transparency and stay accountable on results, yes, we can do that, right? Let me quote a couple of examples here in terms of what we really mean by when it comes to fairness, right? A simple example I can quote here is this is one of the largest lending companies in North America, and this company, of course, offers capital to, or rather the funding to startups who wants to basically build systems and build applications, right, in the startup world. Now, dominantly when, by the way, there was a machine learning model built before going live. Yes, this machine learning model was put into production. Of course, put into production in parallel to the human agents looking at data, looking at applications, and either accepting or rejecting their lending requests. Now, when this study was done, it was very evident that yes, the system always favored male borrowers. I mean, that's not fair, right? So, in fact, because the machine learning model was built, was put in production in a shadow mode, this anomaly could be detected, and hence, because of the fact that there was a gender bias coming on right off the bat, you could actually go back and fix it, right? So the point I'm trying to make here is yes, systems at times, what outcome it gives depends on the data that historically exists with the company. In the case of this lending company, it was true that in the past, the human agents favored male borrowers, was ahead of female borrowers. The same bias was baked into the machine learning model, which again led to inferences being not favoring female borrowers, right? This is one example of need for somebody to be fair. Now, talking about transparency, yes, this is again one other classic model that's been built in India, built for Apollo Hospital in collaboration with Microsoft. Microsoft and Apollo Hospitals collaborated to build a cardiovascular risk score for the country, right? That means anybody who walk into Apollo Hospital, as you get your test done, the model actually predicts whether, basis the clinical trial data, whether this person will have an episode in the near future or not, of cardiology, of course, right, or cardiovascular. Now, End of the day, for a doctor, if the system is telling that, you know what, look at the parameter, this person may have an episode in the near future, hence as part of proactive wellness, recommend so-and-so lifestyle changes. On what basis should the doctor believe? Because as per doctor's data, it doesn't look like this person may have an episode, but system is conveying that yes, there are chances that person may have an episode. Now, this is where transparency is essential. This is where system should actually be a lot more descriptive in explaining as to why the system feels this person may have an episode, right? So, couple of examples I've quoted, which is, of course, which is fairness and transparency. The point is, for us to demonstrate these things in real, for us to ensure that accountability takes center stage, security has to be central to how these models are built, privacy has to be maintained. But if you look at privacy, security, accountability, transparency, fairness, all these aspects, it can't be done unless you're equipped with certain tools which will complement the need to make it happen in reality. And that's where, as Microsoft, our onus to equip you with responsive machine learning tool set has come a long way in making it real for ML practitioners and data scientists. Now, as part of responsible machine learning principles from Microsoft, yes, we go across three categories here. One is, of course, we talk about understand, which is the first, I would say, phase, wherein we give you tools. Of course, there are open source tools being lit up in our Azure ML service, which is on interpretability and fairness. And second, of course, protect. How can we ensure we can safeguard private data? How do we ensure we secure data, right? Of course, all of us understand that public cloud is used to train data, and once trained, you deploy to edge devices, right? So when you're training in the public cloud, how can we ensure the data is secure? How can we ensure data is still encrypted? Can we do computation encrypted data? Yes, we'll look into that, right? And of course, third one is audit trial. This is where ML ops comes into the picture. Now, with this context, right, when it comes to responsive machine learning, there's a need for us to understand a few tools, and this is something that that's something that we will look into in the next 15-20 minutes or so. And yes, if you're a data scientist or an ML practitioner on Azure machine learning, if you're using Azure machine learning, yes, you're in for a treat today, because end of the day, we are helping you stay productive with the tool set, which will complement the complete circle when it comes to ability for us to understand, protect, and audit. So the complete chain that you see there is been lit up with tools, and that's probably is a blessing in disguise. End of the day, as Microsoft, we're committed to make it happen for you as a data scientist or ML practitioner, providing tool chain for you to address responsible machine learning design principles in a big way. So without much ado, with this context, let's dive right into understanding these tools and techniques which will help you uphold the flag of responsible machine learning as you build these machine learning models. Now we'll look at three elements, right? Number one, we'll check on fairness, which is again Python library being incorporated into our machine learning studio. You can call it ML service on Azure. We look at how that helps us interpret the outcome of a model in a very I would say visual way. So let's jump right in and look at fairness ML to start with, and then we'll move into Interpret ML, which is the second open source library that has come into ML service. Right? Let's start with fairness ML. Yeah. So as you see on my screen right now, this is basically an open source toolkit. You can absolutely do pip install, bring in the fairness contrib into Azure ML, and yes, ignore the visual for a minute, and we'll get going right away onto the portal. Yeah. So I'm right now in Azure Machine Learning Studio, right? So end of the day, you need to have a subscription. You need to create a workspace in Azure Machine Learning Service, and eventually you'll land up with an ML Studio. And here I'm going to choose a notebook, right? So we'll just get into importing fairness contrib lib in Python, and eventually look at again an example that I quoted earlier, right? For the purpose of the example, we'll look at dataset, which is census dataset, right? So we'll use again it's an adult census dataset which we load using SHAP, right? So for people who are not familiar with SHAP, which is basically shapely additive explanation is the full form of that. And again, it's a unified approach to explain the output of any machine learning model. Okay, so we use SHAP here as a means for us to interpret the model, and we look at how fair the outcome has been. Okay, so as I said, this is again in Jupyter Notebooks within ML Studio. Now this is where we're bringing in importing specific Python libraries. No need to explain that. We basically are going to use SHAP to bring in adult sense dataset, right? So we will use dataset to train a predictor, right, to predict whether previously unseen individuals, right, as I give a new information, what is the accuracy under which it will predict whether this person will repay a loan or not. Accordingly, you will decide whether to offer a loan, a fresh loan to the individuals who are going to come on board. Okay, so again, let me just run this just to make sure that I have this new run that I can record it. Yeah, so pretty much splitting the data into train test, and getting here, ensuring that the right parameters are set in terms of genders and ratio, training the classification model, and eventually classification for the final classification whether to give loan or not. But eventually the workspace gets registered. I'm going to create a test fairness census demo as an experiment, and that should get recorded into my experiments tab as a fairness preview that we have right now on Azure. So if I go to experiments while it is happening, I'll see previous run. By the way, the latest run is run 3, but right now we're looking at we look at the third run. Let it load. This what we've done right now is, we basically created an experiment, and we're posting those fairness explainability aspects into the portal for visualization. So as you see here, run 3 is also completed. I had the 3 runs before, so let me just open the latest run. And as you see here, yes, there are multiple tabs here. Ignore that. So the extreme right, fairness preview, as I'm highlighting right now. Of course, explanations, which is interpret ML, that is there. We'll get to the explanation preview, but the explanation as a preview is true with most of the services we offer in Azure. If you look at automated machine learning, yes, model explainability comes under that umbrella, so that's also true there. So let's look into fairness, and this is where the regression classifier and a binary classification eventually happens here. So just to give you a bit of a explanation on this right now. So there are sensitivity features that we're going to choose. Whether you want to understand the model outcome from a race standpoint, there are 5 unique values that you saw that we but the race is white, black, Asian, Asia Pacific, Islander, American Indo, Eskimo, etc. Right? So these are 5 unique values that we've chosen. When it comes to gender/sex, female and male. So we're going to choose these sensitive features as we understand the fairness in terms of the outcome. Okay, this is step number 1. Let's choose race to start with, and as I click on next, this is where you can choose how you want to measure the performance, right? So end of the accuracy, which is the fraction data points which are classified correctly. Precision, where data points classified correctly among those which are already classified as 1, right? So that is basically true, right? So, and the recall and balanced accuracy. Let's look at accuracy and let's jump right in. Okay, on the whole, from a statistics standpoint, yes, there are 2 sensitive features, and there are about overall 6513 instances of these occurrences there. So let's look at right in on the accuracy. So by the way, while you're seeing this visualization here, yes, this is again thanks to Fairlearn, right, as the Python library, FairML Python library, and that's been used to assess the data and eventually post visualization into ML Studio. I mean, because of that, ability for us to pretty much look at this confusion matrix, right? End of the day, our intent is to reduce the false positives, false negatives, right? So this is where the false positive, false negatives are indicated, with an accuracy value that we chose against. Our measurement criteria was accuracy, hence you see that here, right? The under predictions are basically false negatives, over predictions are false positive, right? So you actually get to understand, yes, when it comes to under prediction, which are the rays against which you're under predicting, which are the rays which are over predicting, which actually helps understand the pattern of assessments that's happening on unseen data. Unseen data is coming into the model for prediction, and at what accuracy, precision is our model predictor, right? This is one aspect. Second, of course, you can see the disparity, right? This is again, there is good explanation here in terms of how to read the chart, but point I'm trying to make here is, yes, because there's visualizations and certain narrative available on these visualization, you're able to first of all look at, yes, we've trained the model for certain outcome, and at what accuracy, precision are the predictions happening. And this is an opportunity for us to go back and revisit data set, right? If at all there is a gender bias, right? Let's go back a bit here. Let me just choose the gender here, and if I look at accuracy against the gender, now this is where there is 92.4% for female and there is 79.4 again for male. Now this is an opportunity for us to understand, are the predictions happening in a very fair way, or is it leaned towards specific gender, right? If at all it is the accuracy of the model, that means, if false positives needs to be reduced, false negatives need to be reduced, looking at this graph, you can actually act upon the data set and understand if there is already any bias that's been infused into the data set. If so, let's go fix that, right? That's an opportunity. And again, we're talking about ability for the model to predict basis the data which has never been seen by the model. So hence, ability for us to understand eventually when we put that into production, with what accuracy and precision the model will actually respond. So if anybody asks us in terms of, hey, while you're saying for this person, okay, let's say a white man, he has applied for a loan. Historically, this has been the trend of white male who've either repaid or not paid. Accordingly, should we give loan to this person, yes or no? If the prediction says yes or no, right? From staying accountable standpoint, the model creator or even the entity of the business should be convinced that yes, it's the right decision is being made, and this decision is being made based on these parameters. That's central to how one has to look at machine learning model, right? So it is not the question of believing in the model for whatever it does. No, the trust factor only enhances as you make the model interpretable for anybody who questions in terms of its model accuracy and precision. Okay, so this is the first one I want to talk through. So the best part is, yes, as you build your models, you can post anyway experiments appear under experiments here, but you have an opportunity to actually post the outcome of the model explainability into the portal here. That way you can actually go and look at these models. Okay, we'll switch gears from now. So we saw fairness as one of the first library when it comes to that being available as part of a Python library in Azure ML Python SDK. Now we'll move on. We'll take the next one, which is Interpretability, and see how that helps interpreting model in a much fine-grained fashion for us to stay accountable on the fact that yes, any decisions being taken, we have to understand how the decisions are being made. That way we can be more accountable and auditable in every sense from a business point of view. So now, as you see on my screen, this is a snapshot. We'll go through a few snapshots and understand the kind of visualizations we get from Interpret.ML, right? So pretty much, if you look at the model behavior, entire model behavior, which we call it as global explanation, we can look at that. We can also look at local explanation, right? Explain an individual prediction in terms of individual feature importance values across data points, and that's absolutely one of the capabilities that we have from Interpret.ML. Again, raw feature transformations, right? You can actually opt to get explanations in raw form untransformed features, right? Otherwise, if you look at, let's say, automated machine learning, you get engineered features. So you can actually opt to pass on the transformation pipeline in the explainer. That way, you get raw feature transformations in terms of explanations compared to engineered features, right? That's something which you'll do for sure. But looking at this visual right now, yes, this is something which the exploration is something which is so key, right? Data exploration, which pretty much displays overview of the data set along with predicted values, right? So here we're talking about, let's say, the visualization quite evident in terms of will a specific employee of a company, would he or she leave the company or would not leave the company, depending on the monthly income, depending on some of the top, I would say, features. On the top right, if you look at it, top K features, we've chosen 8 of them. And you can understand whether over time, number of companies that person has worked previously, job satisfaction, all those data points comes in handy. On the bottom left, in terms of whether job satisfaction as a feature, would that have an importance when it comes to model outcome, or even when it comes to summary importance across top I was chosen features. So this is a basic visualization. I would not say basic because these are quite well interpretable visualization in terms of exploration, global importance, right? Exploring the explanation as well as summary importance, right? That's something which is very evident. But if you're looking at local importance, right? Local explanation, I would say, in terms of the feature importance, what features has led to, what are the dominant features which is contributing to the probability of a predicted class which is leaving in this case, right? If the probability is 0.73 and the predictions are happening in terms of a person, yes, 73.1% of the time the person is predicted to leave the organization. What are some of the top features which are given importance for that prediction to happen, right? This is again, easier when it comes to the outcome being shown in a visual format. Otherwise, pretty much a data scientist would spend significant time exploring data, as well as when it comes to interpretability, these visualizations have to be generated. So Interpret ML as a package is giving you out of the box explanation when it comes to the values being predicted. Now, another interesting one here is perturbation exploration. So what exactly happens there, right? So as you see in the visual right now, the what if analysis, right? It actually allows changes to feature values of a specific data set you've selected, data point I would say you selected, and observe what will be the resulting change to the prediction value. I think that's something which we're seeing right here, right? End of the day, the base value is so and so. You're changing specific observation so that you can see what will be the eventual data. For example, here, yes, the base value was 73.1 probability of a predicted person leaving, and if you choose business travel to be frequent traveler, what would be the eventual outcome? Right? That's pretty cool, right? End of the day, you can play around with this and do what if analysis, and this is also an opportunity for a data scientist to look at when it comes to going back and fixing data, right? In terms of if there are wrong predictions being made, if some of the features are wrongly interpreted as the model was getting built, there's an opportunity for data scientists to reflect on that and go back and fix it. Yeah. So this is one cool capability. Now, if you move along, right? If you're looking at this dashboard right now, again, in terms of individual conditional expectation, right? This is basically allows feature value changes from minimum to maximum value, right? In terms of, yes, leaving or not leaving is what we're looking at. Predicted probability. What will be that predicted probability if you specifically consider one of the features, in this case, job involvement, right? So this actually helps illustrate how the data points points prediction changes when a feature value or a feature changes here. That's one of the classic example of how valuable these values are. Right now, let's look at when it comes to visualization in ML Studio. Right, so I'll take you through a simple automated machine learning example I ran. If I can switch to the portal. So this is again, I've chosen Dataset, which is about predicting the price of an automobile. Right, as you see on the screen, let me just switch to automobile machine learning tab, and I've done quite a bit of experiments here. It's a regression problem. Now, quite a few runs have gone here, but let's choose one specific run, which is run 27, and let's look at the model. As you may know by now, automated machine learning pretty much, as long as you know whether it's a regression problem or a classification or forecasting problem, it runs across a dominant algorithms under that category and gives you output. So here, for automobile price prediction, I've ran this across a regression here, and again, ensemble model was enabled. Hence, eventually it gives you an ensemble model. But I've enabled explanation for the eventual I would say outcome that came here. While I have the choice to go through any specific model here, so explanation was enabled for ensemble. So let me go and explore that. Right. So as explanation tab is enabled there, this is where the ML Studio makes a huge difference. Right. If you want to basically upload explanations to ML learning history, you can do that here, and this is how it pretty much lands up in the global portal. So whether global importance or summary importance, I can look at that, and again across what number of features, different chart types I can explore. But while I'm showing you the portal in terms of how the information looks here, the point I'm trying to make here is, yes, ML Studio gives an opportunity to upload the experiments onto the portal studio, and hence ability for you to maintain this here, and ability for you to again play around with different visualizations, number of features you can increase or decrease, and see what will be the eventual feature importance. All the stuff can be done here. Right, this is how it pretty much lands up in ML Studio. Okay, so another interesting thing here is if you can look at interpretability at inference time also. Imagine I'm trying to let's say I have an endpoint here. Right, let's look at the endpoints. If I go to my endpoints, I might have a automobile price prediction endpoint here. Right, as I'm predicting this particular endpoint, right, I mean as I'm predicting outcome of a specific automobile depending on some of the features, can I enable interpretability? Right, that's something which will be of super value to anybody who are actually accountable to explain to the management, to the C-level in terms of why, what, and how of outcome. Okay, so this is about the first one, as I said earlier. Yeah. So this is about if you look at the screen right now, yes, this is about the understand part of it. Right, we've kind of gone through two packages when it comes to responsible machine learning. One is of course Interpret.ML, and second is about FairLab. These two packages are active, available within ML Studio for you to stay accountable and build responsible machine learning models. Now switching on to Protect, which is where some of the key innovations have come into the fore in the recent past. So let's look into that right away. So I'll see in the screen right now, the second pillar, which is Protect. We'll look at confidential computing. We'll look at a very cool innovation called Project Seal, which is basically homomorphic encryption. And of course, another open source library, which is called Presidio, when it comes to data production, right, in terms of text as well as images. Let's look at that, right? To start with, let me just move on. Okay, so first things first, let's look at confidential computing, what exactly it is, right? So end of the day, it is about protection of data in use, right? So what does it really mean? Of course, sometime back as Microsoft, we announced something called trusted execution environment. The philosophy is simple. End of the day, when it comes to the code and the application, so they reside in what's called as an enclave, right? So end of the day, the processing happens within that context, in an enclave, and nobody will have access to that particular entity of a hardware component. So let's look at that. In fact, Azure is the first cloud provider to offer confidential computing in a virtualized environment, right? It's a VM-based approach towards giving you or securing your data, and ensuring we give you a trusted environment as part of overall computing infrastructure, right? So let's look at that. But end of the day, it is about understanding the need, right? So if you look at existing encryption, yes, we have the techniques in place when it comes to data at rest, data in transit, right? But what about data when it's in use, right? When it's being computed within a RAM environment. So how is that? How can we secure that? Is the question. That's where Intel SGX enabled virtual machine comes into the foray, and that's what is announced recently. Yeah. So looking at this particular visual, what is the need for us to protect data in use, right? So end of the day, we deploy applications to cloud, and that's where it's running. We have data and applications available in that environment, and computing happens, right? But the element of confidential computing talks about how do we ensure we create a specific execution environment within the memory, where the application data functions for sure, computation happens for sure, but in a way where nobody else can access that, right? Not even while you're debugging. That's the best part. So we call it enclaves, right? Enclaves basically are secured portions of the hardware's processor and memory, right? So there's no way to view data or code inside the enclave. Even with the debugger, right? When we want to debug an application in production, we want to see, hey, what happened if there's any anomaly or an exception. So there's no way for anybody to debug it. If you look at the exposure of an application and data, as you see on the screen right now, it pretty much cuts across all of these entities, right? Be it guest OS, anybody can hack into it. That's something which all of us try to secure the endpoints. There's kernel, there's hypervisor, an admin, right? So end of the day, when it comes to cloud provider, it may be your customer, it might be you hosting it, but end of the day, there are admins who can access your system. So can we ensure the data and application is secure in that construct? The answer is yes. Fundamentally, think of this environment as a secured box. You put encrypted code and data in a box, right? That's what we're talking about. Now, if you look at the use case, yes, we're talking about data sharing in the cloud. One of the classic use case for machine learning. This is where, when you talk about responsive machine learning, the question is, how can we ensure we can secure data for every single party who is participating in a consortium-driven approach to problem solving, right? Let's take a healthcare example where multiple, I would say, healthcare institutions upload information of patient data for building a model which will benefit largely the healthcare as a domain. Now, each of them would upload information, upload data, but how can we ensure while the computation happens, data is still isolated? So as patient data is uploaded onto the cloud, how do we ensure data is secured in a multi-party data sharing environment, and that way the admins or anybody for that matter cannot see the data on their environment? I mean, that's the best part of it. So the point here is, yes, machine learning development, or the field of AI needs massive corpus of data. And talking about a use case here, which is healthcare, yes, if it's a consortium-driven approach, we get data contribution that's going to happen from multiple healthcare institutions, and that's where such a hosting environment where the data and the application acting upon it is secure. That way, we're talking about ensuring that computation happens in the cloud, computation happens on encrypted data. That's the best part. How can we ensure computation, for computation to happen, you don't have to decrypt it, right? Encrypt data computation and then return back the results in an encrypted fashion. That's where Azure Confidential Computing, which is basically the DC SV2 series of virtual machine that went into general availability recently. This is one of the recent innovation, and Azure is the first and the only cloud provider to bring in such innovation to the foray. Okay, again, this qualifies brilliantly under the umbrella of Protect. Now, the second one, which is again one of the innovation which has been there for some time now, but considering the fact that we live in a world where model development happens relentlessly across the board with massive corpus of data, but when it comes to training in the cloud, that's the dire need. That means you have compute in the cloud, you train your machine learning models in the cloud. But how cool it would be if you can upload information to the cloud in an encrypted fashion, and training happens on encrypted data, and results, again, when the model development is complete, you get it back to the edge environment and deploy it. So that's where this technique called homomorphic encryption comes into the foray. That's something which has been in talks for quite some time now. This is again outcome of Microsoft research. There was an announcement that happened some time back where it was open sourced. You hear the term called Project Seal. That's something which has been open source available in GitHub. But let's look at that to understand a little bit more of how that happens, right? If you look at traditional cloud storage and computation, yes, there is a privacy barrier between public cloud, here in this Azure, and eventual, I would say, the customer or the hoster. So information in traditional cloud storage happens by way of symmetric or a public encryption, right? So you basically encrypt data, send it to the cloud, and computation happens, decryption happens, computation is done, then it's encrypted and sent it back to the consumer. Now, again, in a public-private key infrastructure, so using public key encryption is done, and decryption happens with the secret or the private key that exists, right? This is a normal. That means for computation to happen, data is decrypted. I mean, that's where homomorphic encryption, which is the code name as Microsoft Seal, comes into rescue here. This is where, especially for machine learning model, very I would say, if you're looking at a secure environment, if you're looking at a secure way to safeguard data and privacy, this is where homomorphic encryption is super valuable. As I said earlier, it's open source, it's available in GitHub, and this is a location that you can take it. And the best part of this is it works across environments, and the wrappers available if you want to use this in either Java or Python. I mean, a lot more languages supported there. That's something which will come in handy as you go along. Okay, so this is the second one. The third one, which is when it comes to securing PII information, right? So end of the day, the information that we send as part of the data contains PII data. How do we ensure we can mask that as information is exchanged across the board? It becomes very key. So this is Project Presidio. Let me just switch to my browser here. So this is a demo for your reference, by the way, and Presidio is a code name. Text anonymization is something which we've done so far. When it comes to identifying, ability for machine to identify, yes, it's a cryptographic information. It's a, let's say, credit card information, date time, employee name, email address, telephone numbers. When you discover such information, or social security number for that matter, when you discover such information, can we ensure we can mask that? Is the question, and the answer is yes. That happens through text anonymization. Now, of course, image anonymization will come in very soon. We'll look at that, because as we exchange a lot of information in the public domain, can we ensure we can anonymize information within the image to secure some of the private information, right? So this basically sums up in terms of what we're looking at from protect standpoint. Of course, the third one is audit trail. So this sums up in terms of what we cover, what are the tools and techniques we have under the protect category. The third one is audit trail. That's where MLOps comes into the picture. MLOps is, again, as we all know, DevOps has been mainstream for some time, and MLOps joins the bandwagon. So that's another day for another topic, but the third one would be MLOps. So just to sum up, we spoke about the fact that as Microsoft, we innovated significantly to bring some of the tools and techniques to the foray to complement the very need to build responsible machine learning models, right? We went through a few tools under understand category, where we spent some time to understand a few open source Python libraries, which is Interpretability and Fairlearn. Then we looked into confidential computing under the umbrella of Protect. We saw homomorphic encryption, how we can securely do computation in the cloud on encrypted data. That's something which is of utmost importance in the world of machine learning going forward. Of course, third is ML ops, right? So in summary, yes, these are the tools and techniques which are new, which are essential, which complement the dire need to embrace responsible machine learning design principles and build machine learning models, right? If I can quote one last example, yes, going forward, if you're visiting any of e-commerce portals, yes, if there are upsell cross-sell that happens to you, you may be wondering why is this ad coming to me or shown to me. It becomes very important as a service provider to help consumers understand the reason behind certain ads being shown or certain products being showcased, right? The transparency part of it in terms of what features we spoke about when it comes to interpretability, certain feature importance that takes precedent when it comes to outcome. So can we showcase those features to the consumer to help them understand the rationale behind the decisions being made, right? End of the day, it is about building a better future. It is about understanding the need to embrace responsible machine design principles and make sure that we build a better society. Thank you so much for this opportunity. And as I said, I always look forward to speaking at Data Platform Summit. The topic is, I would say, it's niche. We could not get too much into the code because end of the day, the need for us here is to understand the rationale behind why, what, and how, which is what we've kind of spent so far. And with that, thank you so much. And you can reach out to me if you have any questions on this email address, as well as you can connect me on LinkedIn. I'll be more than happy to connect and share my experiences, and we can continue interactions from there on. Okay, thank you so much, and you guys have a wonderful evening, and I'm sure you've had a wonderful Data Platform Summit so far, and good luck to each one of you.